This is the first ever C1 paper, so it's over 10 years ago now. I'm going to start trying to get all of the papers up on YouTube. So let's get going. 16 to the half, we know that's the square root of 16. This is obviously a non-calculator paper, that's 4. 16 to the minus 3 over 2 is 1 over 16 to the 3 over 2, which is 1 over the square root of 16 cubed, so that's 1 over 64. Simple rules of indices there. They've obviously tried to make it easy to get started here. No nasty powers or anything like that, so let's just get on with it. dy by dx is equal to 15x squared plus 7. d2y by dx squared is this differentiated. Notice the 7 disappeared just like the 3 disappears here, so that's going to be 30x. Okay, slightly harder, so obviously more marks available for this one. We need to write it in indice form first, so that's 1 plus 3x to the half minus x to the minus 2 dx. So this is equal to, well, the 1 integrates to x, the 3x to the half, we need to add 1 to the power, which is, add 1 to the power, that's 3 over 2, x to the 3 over 2, and minus 2, add 1 to that power, and we get minus 1, x to the minus 1, plus c. We need to tidy that up, so that's x plus 3 divided by 3 over 2, which is 2x to the 3 over 2 plus x to the minus 1 plus c. Okay, let's get going. Here's the next question. Question 3. There's another question lurking over there. We'll just ignore that. Question 3. It talks about equal roots for this quadratic. So we're told because it's got equal roots, we know b squared minus 4ac equals 0. Okay, if you were to draw the graph of it, it would just touch the axis. Okay, so b squared minus 4ac is 0, so that's 12 squared minus 4 times k equals 0. Okay, so that gives me 144 minus 4k squared equals 0. So 4k squared equals 144. K squared, 144 divided by 4 is 36. It does say k is a positive constant, so k equals 6 because k is positive. Otherwise it would be plus or minus 6. Okay, so we're moving pretty nicely. Let's get on to question 4. Hopefully we're still in our comfort zone with question 4. It's a substitution question. I'm going to substitute for x, but we could equally substitute for y, because x equals to 2 minus y. So we've got 2 minus y squared plus 2y equals 12. So that's 4 minus 4y plus y squared plus 2y equals 12. Do square properly, do no fuss squaring it. There we go. We still want to be accurate here, so that gives us y squared minus 2y. Now we've got 4, but the 12 coming over from the other side, so that's minus 8 equals 0. That hopefully is going to factorise, which of course it does. We're going to have y minus 4 and y plus 2 equals 0. So y equals 4 and y equals minus 2. So we put 4 in there, put 4 back into this, and we're going to get x equals minus 2 and y equals to 4. So and x equals to 4, so in this case x equals 4. So that's it, 6 easy marks. I might go back and check that this all works. For this solution, for example, does it work? Put minus 2 in there, we get 4, plus 2 times 4, which is 12, so that's correct. And for this one, put 4 in there, that's 16, minus 2 times 2, which is 12, which is correct. And of course they do both add up to 2, so it's definitely right. So there we go, we can move on. Okay, so here we've got the first 3 terms of an arithmetic series that we have. U1 will be equal to, now it'll be 2 times 1 minus 5. So that's equal to minus 3. U2 will be equal to 2 times 2 minus 5, so that's minus 1. And U3 will be equal to 2 times 3 minus 5, which is equal to 1. So that's our first 3 terms. You don't need to write all that. You probably would have been okay just writing them out. Notice the common difference is 2. So that gives us our answer to B, which is common difference D equals to 2. And now it's saying so that sigma 2r minus 5 equals to n minus 4. It's right. I'm not going to write. We're asked to show this. I'm not going to bother writing out just what I'm asked to show because that's in the question. We need to get from here to here. So that's got to. That's obviously got this. A equals the first term is equal to minus 3, and D equals 2. So that equals to, there is a formula in the formula book for the sum of a series, which is Sn is equal to n over 2, 2a plus n minus 1 d. That's our formula that we're going to use. You don't get any marks for just quoting formulae, so we just have to use it appropriately. So let's write this out again. N to r equals 1, that equals to n, which is n over 2 from here, 2a, so it's 2 times minus 3, plus n minus 1 times d, which is 2. So that's n over 2 times minus 6 plus, multiply this bracket out, 2n minus 2. So that equals to n over 2, 2n minus 8. So we can see that if I half each of these terms, I'm going to get what I need because I've basically got a half here. So that's okay now to just say n minus 4. Don't have to write as required, but it's a little bit of pompous maths that I like to do as required because we're asked to show something. And we've shown it, so we actually said that it's done. Okay, on to the next question. So here we have, this is a reflection, because if you think about it, this is going to swap the coordinate of the y coordinate here. So we're going to have, basically this is going to be a reflection. Because the y coordinate changes sign, this is going to be a reflection in the x-axis. So it's going to be doing like this with this coordinate here, swapping. So this now, let's call it p dash, 3, 2. And then of course it's still going through 2, 4 because it's been reflected. Okay, nice easy 3 marks for that. This one, notice it's inside the bracket here. So here, so for every coordinate, the y coordinate is unchanged. But the x-coordinate because it's in the opposite sense with the 2. So the x-coordinate is times by a half, or divide by 2 if you prefer, because it does the opposite. Because yeah, it'll just do the opposite of what it should be. Let's look at these two. We've essentially got 3 points, haven't we? We've got 3 coordinates, 2, 0. Let's say the y bit's going to stay the same, so that's 0, and the x bit is going to be halved. And 4, 0, the y bit's still going to be 0, but the x bit is going to be halved. And then we finally got the point 3 minus 2. The y-coordinate is going to be unchanged, but the x-coordinate is going to be halved, so that's 3 over 2. Essentially what's going to happen is it's going to come inwards like this. I'll draw it separately here, because I think the original thing had 2 separate things in the answer book. So it's doing this. It's basically squashed horizontally, where this point here, you can call this P double dash, is 3 over 2 minus 2, and it's also going through the point 1 here and 2 here. So we're making good progress for here, question 7, and not even 12 minutes in. This is a differentiation question now. The first thing we're going to need to do is separate out the bit here. So that's equal to y equals 4x squared plus 5 over x minus x over x. So y equals 4x squared plus 5x to the minus 1 minus 1. Okay, so differentiating that gives us dy by dx. We're using the rule y equals x to the n, so that gives us 8 gives us dy by dx is equal to nx to the n minus 1. So that gives us ax to the 1 minus 5x to the minus 2, and the minus 1 goes. And it says show that the value is at p is 3, and p is the point with x coordinate 1. So dy by, when x equals 1 at p, so that again, at p x equals 1, and dy by dx is therefore equal to 8 to the 1 minus 5 to the 1 minus 2. This is all non-calculator, but 1 to the power of anything is 1, so that equals 3 as required. Okay, so that's part A done. 5 fairly straightforward marks. It says find the equation of the tangent to C at P. Well, what do we need to know for the gradient of a tangent? Well, we need to know, the equation of a tangent, we need to know the gradient, which we already have, and we need to know the x and y coordinates. So we need to find the y coordinate. So we're going to put that into the original xy equation at the top. Which is that equation here, y equals 4x squared, 5 minus x, so y equals 4 to the 1 squared plus 5 minus 1 over 1. So that makes that, it's easy to see, 1 squared is 1, 4 plus 4, which is 8. So we've got the point 1, 8. So I'll just put it up here now. Y minus y1 is the equation we're going to use, the equation of the line. So we've got y minus y1, which is 8, is equal to 3x minus 1. So that makes it y equals 3x minus 3 plus 8, so that's 3x plus 5. Okay, so now we've got part C. Part C is just to find when y equals to 0. Basically, this is going to, don't need a graph, I'm going to do it anyway. 5, it's got gradient 5, and it's basically asking for the coordinate of that point. And to find a coordinate, we equate y equal to 0. So we've got y equals to 0, so 0 is equal to 3x plus 5. 3x equals minus 5, x equals minus 5 over 3. So this point is, so we've got k equals minus 5 over 3, because they've just called it k. They've called this point here k0, the particular value of y, of x when y equals 0. Okay, so I might have, thinking about it, it's not wrong, but let's just put k here to be consistent. So I don't need to write it twice. There we go, it's done. Okay, next question. So waiting for something to be tricky so far. I don't know, Scott, maybe we'll find something a bit challenging here. It's only 7 marks there, so I wonder. Right, so we've got a diagram which helps us, and it says find the value of P and Q, which is the coordinates of this. What does it tell us about the points here? It says that D is the midpoint of AC. Okay, well that's quite useful. So we've got the midpoint of this. So we've got the midpoint of the x coordinates. So we've got 1 plus p over 2 is equal to 8. It's pretty easy to see from that, because the top that's got to be the top has got to be equal to 16 for that, so that gives us p equals 15. And similarly, we've got 7 plus q over 2 is equal to 2. Now we can see this q's got to be negative, it's below the line anyway, so it's kind of fine. So the top has got to be equal, I'm not doing any rearranging here, I'm just using common sense. The top has got to be equal to 4, so q must be equal to minus 3. Okay, just haven't bothered with doing any algebra there, and some people might do that in their head, which for a 2-mark question you'd get away with just writing this, to be honest. When it's more than 2 marks, you probably want more justification. Okay, so now let's talk about the next part. It says the line L passes through D and is perpendicular to AC. So it passes, it's perpendicular to AC, like that, and it intersects AB at the point E. Okay, so find an equation for L in the form AX plus BY plus C equals 0, where A, B and C are integers. Okay, I have a feeling I might have left a part of the question out, so we'll just go and bring that up in a moment. There must be a part C here, because there's no mention of E in part B, so we'll find that in a sec. Anyway, let's get on with it. We've got the gradient. We need the gradient of AC first of all, and I'm going to the formula I'm going to use is m is equal to change in y over change in x, or call it delta y over delta x, or whatever, whichever you prefer to call it. Okay, so we've got m is equal to the value of q, which is minus 3. minus 7. So that's minus 3 minus 7. All over this value here, p, which is 15, take away 1. So that's minus 10 over 14. So that's minus 5 over 7. Okay, at this point I start thinking, well, I've got a negative gradient, does it look negative? And yes, of course it does, but we don't want the gradient of AC. That tells us that then the gradient of DE is negative the reciprocal of that, so that must be 7 over 5. Now we've got everything we need to know. We can use any of the, oh no, we've got to use point D. We have the point D, which is 8, 2. And we know the gradient of this line is 7 over 5. So we can use y minus y1 equals mx minus x1. We used in the last question, where it's not uncommon to have a couple of questions using that. So we've got y minus 2 is equal to 7 over 5 x minus 8. Okay, checking I've got my y's and x's the right way around, because it's easy to make a mistake here. So let's multiply that out by 5. So 5y minus 10 is equal to 7x minus 56. So that gives us 7x minus 5y minus 46 equals to 0. Okay, so that's, I notice we have to have it in that form. These need to be integers. Okay, if we have fractions there, then it's not going to be right. So it's asked specifically for that form. These have got to be whole numbers. Okay, so let's move on. I'll just pull up part C because there must be a part C. And here it is. Okay, it was, I suppose, could have predicted what it was. Find the coordinates of point E. Well, we've got this equation here. And the one thing, this line here is basically the line where y equals 7. So we're looking for the coordinate where y is 7 on here. So we just need to sub in 7. So 7x, so y equals 7, minus 5 times 7, minus 46 equals 0. So 7x minus 35 minus 46 equals to 0. Right, so it's 51, 81. 7x equals to 81. So x is equal to 81 over 7. So the coordinates of E, because it does ask for the coordinates of E, so we better write them down, are 81 over 7 and y equals 7. Okay, just a couple of questions to go. They are getting a bit longer now though. Here we've got an expression for dy by dx. I suspect the part B is going to involve integrating. So this is the kind of thing they like to do because there's no integration involved here. It wants an equation of the normal. Now we've already got an expression for dy by dx, so we can find a gradient easily, and we've got a coordinate. So they like to do this because often people behave like machines. So you think if you've got an equation of a normal, you've got to differentiate, but you don't because we already have dy by dx. Okay, so here we go. So when at P, so when x equals 1, what's happening there? When x equals 1, dy by dx is equal to 3 times 1 minus 1. squared. 3 times 1 minus 1 is 2, square that as 4. Now that's the equation of that would be the tangent. So the normal, or gradient of normal, should I say, the gradient of the normal is minus 1 over 4. So we've got y minus y1. We've actually used that third time on this paper now. Y minus y1 equals mx minus x1. So we've got y minus 4 is equal to minus a quarter x minus 1. Now they haven't asked for it in a particular form here, so they've talked about an equation. It probably means that we're okay to leave that here like that, and that's going to get us full marks, but I'm going to change it just in case. So 4y minus 16 is equal to x plus 1. So we have 4y minus x minus 17 equals to 0. But I don't think, as I say, when it talks about an equation, probably any acceptable form of the equation is okay. Right, then, so part B is going to be our integrating, as I say. We've got dy by dx is equal to 3x minus 1 squared. We clearly need to multiply this out. Square 3x squared, so that's 9x squared, be careful. We're going to have a middle term, that's going to be this number times this number, times 2. I like to think, basically what I'm using is a minus b squared is equal to a squared minus 2ab plus b squared. So basically, double we're going to have a minus here, double times the a and b together and double it. So 3 times 1 is 3, and double that, that's minus 6x. And of course, don't forget it's plus 1. So now y, we're going to get y by integrating 9x squared minus 6x plus 1 dx. So we get y equals 9, that's going to be 3. So it's going to be 3x cubed minus, now here we're going to add 1 to the power, so that's x squared, divide by that number 3x squared plus x plus c. Probably did that without explaining what I'm doing, because I'm sure most of you know what I'm doing. Basically we're using x dx is equal to add 1 to the power, divide by that number, plus c. So for the 9x squared, for this 2 here, I added 1 to the power, that's 3, and divided the 9 by that and got 3. Now, that would normally be it, but we can work out c because we're given a particular point. So at p, so we can just say when x equals to 1, y equals 4. So we have 4 is equal to 3 times 1 cubed minus 3 times 1 squared plus 1 plus c. So that gives us 4 is equal to 3 minus 3 plus 1 plus c. So that gives us c equals 3. So y equals 3x cubed minus 3x squared plus x plus 3. Right, slightly unusual question C, trying to get you to show something that should be kind of obvious. The thing is, this has got a negative gradient, but this can't be negative because we're scaling it. So we've got dy by 3x, dy by dx is equal to 3x minus 1 squared is greater than 0, since squaring. Since we're squaring, for the exam purposes, you could just say that it's greater than 0 because it could be equal to 0, of course. So be careful. So greater than or equal to 0. Okay, but gradient of line is -2. So that means there's no tangent. Okay, that's question 9. Right, we're on to final question. Just slowing down a bit now. We're up to half an hour. We're basically completing the square for part A. There is a formula for completing the square. X squared minus plus bx plus c is equivalent to x plus b over 2 squared minus b over 2 squared plus c. But basically all we're doing is well, of course this could be minus as well, so whatever the sign of this is, you keep in the bracket. So you could have a minus here as well. Okay, but basically all we're doing is we're halving the value of b and taking away the square of whatever that value is in the bracket. So fx, which is equal to x squared minus 6x plus 18, just writing the question out, is also equal to x minus 3, half that number, take away the square of that. Okay, it wouldn't be wrong to put a minus in there, but it's not necessary either. Plus 18. So then that equals to x minus 3 squared minus 9 plus 18. So that's x minus 3 squared plus 9. Right, okay, so now it talks about page 19. Of course, we haven't got page 19. It wants us to do a sketch. Let's draw some axes. Okay, so we've got some axes there. We can see that the vertex of this graph must be at 3, 9. The reason being, it doesn't ask for the vertex, but it'll help us for the sketch. The reason being that the least that this can be is equal to 9, because similar to what we were saying in the previous question actually, x minus 3 squared must be greater than or equal to 0. It will be equal to 0 when x is 3, and therefore the least point will be at 3, 9. Basically, as a general rule, you will be changing the sign of this one but not changing the sign of this one. So the minus 3 becomes plus 3 and 9. So that's a vertex, so it's 3, 9. And that's our point Q. Probably is wise also to put the point where it crosses the axes there. I'm not sure whether that's in the scheme or not, but it's a good idea to put it. Okay, and then it says for the final bit of the paper, part C, it's basically saying there's a line y equals 41. Obviously this is not to scale. Find the coordinates as a surd. Because they haven't actually done any work on surds in this paper, so they've obviously tried to fit it in here in a slightly half-baked way, because it's not particularly, it's not very long, so all that rationalising of the surd is missing and all that here. Right, so we've got y equals 41. I'm going to use the completed squared form. You can use the formula though, if you want. Okay, you could put the 31 into here. 41, so they say, and then use the formula, that thing. But I'm going to use the completed square form here because I think it will work out quite nicely. So we've got x minus 3 squared is equal to 32. So x minus 3 equals to plus or minus the square root of 32. Now, square root of 32, let's write this in a different colour, is equal to the square root of 16 times by the square root of 2. So that's 4 the square root of 2. So that's equal to plus or minus 4 the square root of 2. So that gives us our values of r, x is equal to 3 plus or minus 4 the square root of 2. Okay, find the x, it only wants the x coordinates of r, given your answer in the form plus, find the x coordinate of r, the line meets C at the point r. Find the x coordinate of r, given your answer in the form where p and q are integers. So there's two possibles, 3 plus or minus 2. And I think that's it. Except a subtle point here. I've only just seen this myself. It's told us that x is greater than 0. So that's going to take out the negative one of these, because obviously 3 minus 4 the square root of 2 is going to be negative. So I didn't need a plus or minus here. So x is equal to 3 plus 4 the square root of 2. Okay, this. Okay. This one here. Okay, so that's the paper done. We've done it in 37 minutes, which is less than half the time needed given. We've started off very quick stuff. We're using surds, then a bit of differentiation, simple differentiation, some integration, use of discriminant, substitution for a quadratic, for simultaneous with a quadratic, then quite a reasonable arithmetic series question using the arithmetic series formula. Then we've got a question with using transformations, got a differentiation question there. Okay, and then the coordinate geometry, that was the one where I chopped off part C. Question 9, little bit of an unusual part C there, but still relatively routine. That was quite the one, they quite like to mix two different topics there. They got a bit of differentiation and integration, same question. And question 10, bit completing the square, that's all done. Okay, so we're all done. Jan 25 finished.